Factoring out a monomial GCF. So the process here is going to be very similar to the previous lesson on factoring out a numerical GCF, but this time it will be a monomial GCF because it won't just be a number, but it will also be include a variable part. So if you think about the previous lesson, our goal is to find out what can I factor out of each of these terms, and remember that once we factor that out, we will be left with a set of parentheses that will have the same number of terms as we did here. So if we start with a trinomial, we'll end with a trinomial, and I'm going to go ahead and put my plus in there and my minus in there right away, knowing that I'm going to have a term plus another term minus the third term, which will be again what remains after factoring out the GCF. If we were going to factor out a negative, things would be a little bit different in here. If we were going to factor out a negative, these signs would change, but we can do more on that as we go in other lessons. So, if you can look at these three terms and know what the greatest common factor for the numbers and the variables are, feel free to put those in there and tell what remains. If you're still working on being able to find those, we can go ahead and list 4x to the third as one of our terms, 20x squared as another term, and 16x as our other term. And we don't need to include the minus because we have that taken care of right here. So 4 is, the factors of 4 are, I should say, 1, 2, and 4. And if we have x to the third, we know that is x times x times x. And this should look familiar to you. Next we have 20, which is 1 times 20, 2 times 10, and 4 times 5. Our x to the second power here is x times x. 16, the factors of 16 are 1 and 16, 2 and 8, and then 4 times 4 is 16, so the factor of 4. And with x, we just have an x. Now if we circle what's in common between all three terms, there's a 1 that's common with all three terms. Notice there's a 2 in all three terms as well, and there's a 4 in all three terms. So the greatest common factor for the numbers is 4. Now we'll look to see how many x's we could factor out of every term. Okay, now again, if we look at the smallest number of x's, that will actually tell us our answer. But remember, we can also look at, okay, x times x times x. Can I take x to the third out of every one of these terms? No, because this one only has x squared and this one only has x. So again, it is always going to come down to the smallest amount that they all three have, which is x. Once we write our GCF of 4x out here, we have to tell what's left. Again, remember, it's like division, so 4 divided by 4 is 1. And if we had x to the third right here, and I should have put a box around those, sorry. Now let's go back here. That means we can take a single x out of every one of those, right? So if we look at the fact that we're taking this 1 out here, how many are left? Well, x times x. We don't say 2x, we say x times x, which is x squared. So we have x squared remaining here. 20, if we factor out a 4, 20 divided by 4 is 5. And again, if we took an x out of x times x, we are left with a single x, x to the first. And then down here, 16 divided by 4 is 4. And we took that x out, so there's no more x here because we took it out. Again, if you look at distributing this back into the trinomial, we will arrive here if we've done it correctly. 4x times 1x squared, well 4 times 1 is 4, x times x to the second, using our power rules, is x to the third. 4 times 5 is 20, x times x is x squared. 4 times 4 is 16, and x with no other x means there's an x there. So we have factored out the greatest common factor correctly. And the second example, we now have a binomial, and if you have a binomial, you're going to end up with a binomial in the parentheses, and we have to factor out a GCF. In between the two terms is a plus, so I will leave that there. All right, so 18x to the fourth, y to the second. Well, 18 has factors of 1 times 18, 2 times 9, and 3 times 6. And our x to the fourth, y squared can be written in its prime factorization, which is x times x times x times x times y times y. And then we have our second term, 48x x squared y. 48 has factors of 1 times 48, 2 times 24, 3 times 16, 4 times 12, as well as 6 times 8. And so we have to squeeze a couple more in there. And then we have x squared y can be written as x times y. And now we're going to go ahead and find our common factors. There's a 1 in both, there's a 2 in both, there's a 3 in both, there's a 6 in both. Is there a 9 in both? No. Is there an 18 in both? No. So our GCF for the numerical portion is 6. And now we'll look at how many x's we have. Again, we're looking for the lowest number of x's because it tells us how many we can take out of both of them. There are 4 x's right here and 2 right here. So we can take out 2 x's, and then we look for our lowest number of y's. And again, we have 2 y's here, y times y, and we have a y here. So it's going to be the single y. So we can factor out an x squared, x times x is x squared, and a y from each. So x squared y. All right, going through finding out what's left, 18 divided by 6 is 3. And again, if we had x to the 4th and we took x squared out, we had 4 of them, we took 2 of them, we have 2 of them left, which is x times x, which is x squared. And we had a y squared, we took 1 of them out, so we're left with a y right here, as you can see right there. And then 48, well 48 divided by 6, well 6 times 8 is 48, so an 8 here. We took out this x squared, all of it, so there's no x's left, and we took the y out as well. We factored that out, so there's no other y's. So we're actually done at that point. Again, we can check that it's right by using the distributive property. 6 times 3 is 18, x squared times x squared is x to the 4th, y times y is y squared. And then we'll multiply this way, 6 times 8 is 48, x squared y.